Woohoo! And welcome back. Today we're going to be talking about solving inequalities. And to make it easier to understand what we're talking about, I invited Thor and Loki to join us. And before we started, I went ahead and looked up, and the actor who plays Thor is 6'3", and we're going to call that height A. And the actor who plays Loki is 6'2", and we're going to refer to that as B. Now, they're almost the same height, but Thor is slightly taller than Loki. And so we've got A is greater than B. So let's look at a couple of different options we have in terms of comparing the two heights. Specifically, dum dum dum, what happens if we put them on a box and we let the height of the box be C? Well, if we let the height of the box be C and they're both on the same box, then Thor, right here, A plus C, is still overall taller than Loki, B plus C. So even if we add something to both of their heights, Thor is still taller. And you're going to see that there is going to be a trend here. Okay. Dun dun dun! What if we subtract from both sides? Now, this could be really gory, but instead what I'm going to do is I'm just going to put them both in a ditch. And if they're both in a ditch and the ditch is C deep, and that would be feet or inches or meters or whatever, but if we put them both in this ditch together, Thor at height A minus C for the ditch is still greater than Loki in the ditch. So whether you add to both sides or you subtract from both sides, this inequality does not change. So that's very convenient. That means that when we're dealing with inequalities, we could add the same amount to both sides or subtract the same amount from both sides and still have a true inequality. So the next question is, what about multiplication? So I went ahead and did some cloning. And as you can see, I've got two Thors and two Lokis, and I just used two because that's what fits. And the idea here is as long as I'm using a positive number, if I multiply on both sides, the two Thors, or 3 or 12, or weirdly enough, 17/37, whatever that picture would look like, if I multiply on both sides and C is positive, the stack of Thors, so the Thor stack, I'm sure this will be common, this will be part of slang any day now. The Thor stack will be taller than the Loki stack. So stacking Thors is going to give us a taller stack than stacking Lokis. And in fact, I tried to draw this in, it's a little hard to see, but even though there's only 1 inch difference between them individually, as you start stacking, the difference in height actually increases, which is interesting. So that leaves a couple of questions. Specifically, okay, so what happens if you multiply by a positive number on both sides? The inequality stands, right? See, the inequality is still facing the same way. But what if you multiply by a negative? And some of you already know when you multiply by a negative, it switches places. And it's really hard to figure out how to draw a picture of this, but I've got an idea. Now, this is not exactly the way the numbers work, but it is a helpful way to remember it. So keep that in mind. This is not mathematically rigorous. This is just a memory aid. But what I'm going to recommend is that we take the Thor stack and the Loki stack to the local playground. And we let them play on the dun 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 monkey bars. So here's Thor. And he's hanging upside down. The Thor stack is hanging upside down. And the Loki stack is hanging upside down. Now, depending on your perspective, you can either look at the height off the ground. So if this is the ground, the Thor stack actually hangs down further, so it's not as tall. The Loki stack, weirdly enough, hanging down because it's shorter, the top of his head is actually further from the ground. So that's a way to remember it. The other way to remember it is if you imagine that we've actually dug a hole in the ground and they're hanging down into the hole, which is, I guess, that probably could be a great movie. They're hanging in a pit and they have to escape or something. But the Thor stack actually hangs further down than the Loki stack because Thor is bigger. So when you switch it around, something that's really big, like 100, when you make it negative, negative 100 is so much smaller or so much more negative. So here is the important one. The important thing to remember, whether you like the Thor stacks or you think it's just very strange, and that's fine. The thing to remember is that if you multiply by a negative number on both sides of an inequality, you have to change the direction the inequality faces because you're flipping you're flipping the way they interact. So let me put this in red so it's really stands out. So I'm going to highlight that. So notice that the greater than becomes a less than. So that's really important. If you multiply or divide by a negative number, you have to flip the inequality. There we go. So if you multiply or divide by a negative, flip the inequality. And now there's one more, and you can already see there's no picture here, so what the heck is going on? Well, if you mistakenly, and I know it feels weird, like you're like, how would you not know? It can happen. You multiply by something, you don't realize that thing is equal to 0, and then what have you got left? You've got nothing. When you multiply or divide, well, you can't divide by 0, but when you multiply by 0, you end up destroying the whole inequality, and there is no inequality left. It just becomes 0 equals 0. And then you've got nothing. So be really, really, really careful when you're multiplying on both sides of an inequality. Make sure you know that whatever you're multiplying by is not equal to 0. Woohoo. Okay, and then really, obviously, if you're dividing, also be really careful. Do not divide by 0. Okay, so we're going to take all of these facts and we're going to use them to start simplifying inequalities. Dun, dun, dun! Okay, so solve and graph. There are two ways to approach inequalities, and one is to always solve to the left, which is the way a lot of people solve their equalities, and the other is to always solve to the positive. And I think we've got time, so I'm actually going to show you this first one, doing it both ways. So I'm going to give myself a big OR and put a line down the middle, and hopefully I'll have enough space. So the first way to do this is to go ahead and to solve to the left. By which I mean I'm going to subtract 10y from both sides. Now, first question, when I subtract on both sides, do I leave the inequality facing the same way or do I flip it around? Well, let's take a look. If I'm subtracting from both sides, that's like putting them both in a ditch, the inequality stays the same. So inequality is going to stick. I end up with 16 minus 17y is greater than or equal to negative 4. And then I'm going to subtract 16 from both sides. Woohoo. I get negative 17y is greater than or equal to negative 20. Notice the inequality has not changed. Now on this next step, I'm going to have to isolate y. I'm going to go ahead and divide both sides by negative 17. In this step, right here, not later, not at the end when you realize, right here at this step when I divide by negative 17, you have to flip the inequality around. And I get y is less than or equal to, this is a negative over a negative, so I get 20/17. Okay, woohoo. So what's the other way we can solve this? Well, the other way we can solve this is the way I prefer. And I know that I am very, it is rare for someone to prefer this, but I really hate negatives. They just annoy me. So what am I going to do to avoid negatives? I'm going to go to great lengths. I'm going to say 10y over here, negative 7y over here, more y's on the right, move the y's to the right. So I'm actually going to add 7 y's to both sides. And then I've got 16 is greater than or equal to 17y minus 4 because I added to both sides, which does not change the inequality. Then I'm going to add 4. Same thing. Adding does not change the inequality. 20 is greater than or equal to 17y. And now I'm going to divide both sides, but this time I'm going to divide by 17. It's a positive number, so nothing changes. So I get 20 over 17 is greater than or equal to y. What is the problem with this answer? Well, the only thing that could possibly go wrong here, pardon me, is that the y is over on the right, and that's unusual. This is still true, but a lot of people have trouble graphing it. It's going to be easier. So what you have to imagine doing is you take this and you just rewrite it with the y first. Now, I'm not going to change their relationship. So who was on the big side? 20/17 was on the open side, right? The part that had the open mouth. The closed mouth is pointing at the y, so it's going to keep pointing at the y. So did I change anything? No, I just wrote it in the other order, which you can always do. And you see, oh my goodness, look at that. We get the same answer. And in fact, the cool thing is if you look back at this, you can see why the inequality flipped. The inequality flipped because in this case, we had to move the y's to the other side. In this case, we never moved the y's over to the right, but right here, when we divided by a negative, we inverted all of the relationships. We turned them upside down on the monkey bars. So, next question. Everyone's like, how do I graph this? Well, I mean, if you have a beautiful line graph and your line graph has a bunch of numbers already written in, be very careful. 20 over 17th is about what? 1.2, 1.1, somewhere in there, I think, right? It's 1 3/17. So it's about 1 1/6. So you can graph it very carefully. For me, I would find 0, find 20/17. Remember that as long as you only have 2 points on your line graph, that can go anywhere. If you try to put another value in here somewhere, then you have to be careful. But 2, you're golden. And I'm at less than or equal to, so I'm going to use the bracket. And I'm going to cheat because I can and use this to draw it in rather than scribbling with black. You can also just blacken it in. Or, of course, you can always do the other method of writing this in, which is the closed circle to mean it can be equal to 20/17 or it's got to be less than 20/17. So anything smaller than 20/17 is golden. Woohoo! Okay, you guys ready? Number 2. Oh no. Dun dun dun. Now, I actually wrote number 2 because in my mind, this is just about as hideous as one of these problems can get. There's minuses everywhere. So it's like, oh no. So what are we going to do? It's a good question. What I'm going to do is realize that I don't like the minuses, but what's actually worse in this particular problem is the fraction. So I'm going to just go ahead and get rid of the fraction. And the denominator is a -5. Now, there are fancy tricks I could use, but I'm going to be honest, I probably wouldn't think of them, especially on a test. I'd be stressed out. So I'm going to see that -5 and want to get rid of it. So I'm going to multiply both sides by -5. And watch the way that I write this. So I've got my -5 written on both sides, but I don't put in the inequality right away. Why is that? Well, I'm multiplying both sides by a negative. If I'm multiplying both sides by a negative, then I have to switch the inequality. Multiply by a negative, switch the inequality. Switch or flip, depending on your perspective. And so over here, the negative 5's cancel. Over on the right, they do not. I get greater than or equal to 10. You know what? I don't like how little space I've got, so let me draw this a little bit lower. Sorry about that. Just so it's easier to follow. Okay, I've got the 10 over here. And then over here, I've got 3 minus x. And at which point I'm like, oh no. Because I realize that if I subtract 3, and remember, subtracting, the inequality does not change. Why did I say, oh no? Well, now I've got the opposite of x. So yet again, another minus. The minuses are just trying to mess with us in this one. And that's why I picked it, just because it's just minus, minus, minus. Those of you who love subtraction and negatives, I'm sure you're like, yay, party. You got the nachos out, you're dancing, maybe there's a disco light. You know, Godzilla could totally get into it, have a negative party. Okay, but I'm not having a party. I do not like the negatives. I'm just like, ugh. But we can deal. What we're going to do is I'm going to go ahead. Now, different people have different perspectives. I actually think of this as being division. Can you multiply both sides by a -1? Yes. Dividing and multiplying by a -1, same result. Except, dun, 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 it's an inequality. So we have to change the inequality back. Oh my goodness. How many times might we have to do this? Oh, it just depends on the problem. Every time if you multiply or divide by a negative number, you have to flip the inequality. Okay, so then I think I've got x is less than or equal to -7. Oh, what was my mistake? I haven't made it yet. But if I put 0 there, where would -7 have? It would have to be over here. Sorry about that. Got excited. And so I'm like, yay, the problem's almost done. Okay, here we go. There's my -7. So if x is less than or equal to -7, we're going to be over there, less than or equal to with either a bracket or, I don't know, I gave it way too much room over here. You know, flair for the dramatic or something. So there's my -7. If you use the closed circle method, you'd graph it like that. And I mean, this is not the only way to do this problem. There are other ways. If you're interested, I could show you a couple elegant ways. But this way, I think, gets the job done. And this would be the, I think, most natural way for students to choose. So this is a fine way, even though you have to end up switching twice, which is like, oh. But hopefully you, like Godzilla, you guys are having a good, happy dance party now, because this all makes sense, I hope. And in the next video, if you watch it, we're going to be talking about nonlinear inequalities. I would really encourage you, after you see this video, to do any linear equality work you have to do before going on to nonlinear inequalities, because they require you to already understand this. So take a break, then do some homework, you know, get out, look at something green, enjoy some sunshine or the rain or the stars, or, you know, your happy little, you know, math cave, whatever you've got. I hope you're having a great day, and I hope you realize how amazing and incredible you are. And I will see you in the next video. Woohoo! Math on.